Tama ko lang ay forensic chemistry. Ayan. Okay? Magpe-present na ako ng slides. Present na ako ng slides. Okay. Kita nyo ba yung laser pointer ko? Kita ba?
Yes po.
Okay. So, our first topic would be the principle of laboratory instrumentation. Next question ko ay kita ba na naka-presenter view ako o hindi? Hindi. Slides yung nakikita? Hello? Hello?
Kita naman po.
Kita na hindi ako slides lang kita, hindi kita yung notes ko.
Slides
Yung
lang.
slide lang po.
Okay, nice. Thanks. May notes kasi ako. Ang kodigo. So, principle of laboratory instrumentation. First, we will be discussing properties of light kasi yung first half nito, yun muna yung discuss ko with base spectrophotometry. So, light is an electromagnetic radiation that has wave-like properties and particle-like properties or photons. Sino ang nakaano yun? Yung particle-like properties, si Einstein. Wave-like properties, ang description nito, may kita natin sa equation na ito, na mga sumusunod. The relationship between wavelength and energy is described by the Planck's equation, wherein E is equal to h nu. H is the Planck's constant, which is equal to 6.62 times 10 raised to negative 27 erg/sec. And nu is the frequency. So, ito nga yung sinasabi natin na yung wave-like property ng light, because the frequency of a wave is inversely proportional to the wavelength, it follows that the energy of the electromagnetic radiation is inversely proportional to wavelength. This relationship is described by the following equation, wherein nu is equal to c over lambda. So it follows that E is equal to hc over lambda, where c is the speed of light. Hindi ko na sinulat dito, pero sa pagkakaalala ko ay 3.00 times 10 raised to 8 meters per second. Tama ba? Ayan. So next, dahil magdi-discuss tayo ng spectrophotometry, important na i-discuss natin yung Beer's law. Beer's law states that the amount of light absorbed by a solution is directly proportional to the concentration of a solution. Conversely, the logarithm of the transmitted light of a substance is inversely proportional to its concentration. So the amount of light absorbed or transmitted is mathematically related to the concentration of the analyte, given the equation A is equal to negative log IS over IR, wherein IS is the intensity of the light transmitted to the sample and IR is the intensity of the light transmitted to a reference cell, or yun yung tinatawag natin blank. Yung IS over IR, ang tawag natin dyan ay yung transmittance. No? So the amount of light absorbed by a sample is defined by that equation. A is equal to epsilon BC. So yung A ay absorbance, yung epsilon ay absorptivity or molar absorptivity, and B is the light path, usually centimeters in unit, and C is in the concentration. So, bago natin gamitin or maintindihan yung Beer's law, dapat malaman natin yung limitations niya. So, incident radiation on the solution must be monochromatic. Kaya gumagamit tayo ng monochromator or filter or pang-filter ng light. Kasi 'di ba, madaming wavelength yung light, yung incident light. Kailangan nating i-filter. Since Beer's law, ang isang limitation niya, dapat monochromatic yung light. Second, the solvent absorption is insignificant compared with the solute absorbance. Ibig sabihin, dapat yung solvent natin, hindi mas mataas yung absorption niya kaysa dun sa solute. Kasi kahit gawin nating blank yun, yung solute, parang makukonstrue lang niya as a noise. Ganyan. Third, the solute concentration is within given limits. So Beer's law to, dapat fina-follow natin. Di ba, pag sobrang taas ng concentration ng solute, merong limit yung Beer's law, di ba? Na pag sobrang taas yung concentration ng solute, na sobrang erratic nung peaks. So, usually ang practice natin, yung peak dapat nasa absorbance equals to 1 lang, usually. ginagawa. Pwede naman lumagpas basta hindi ganun ka-noisy. Ayun. Fourth is that there is no optical interference. Meron ngayong calculation nito, dapat na alam natin dun sa analytical chemistry yan. Meron siyang calculation yan, yung optical interference. Pero hindi, chill lang to. So hindi tayo analytical chem na subject. So ni-describe lang natin. So a chemical reaction does not take place between the molecule of interest and another solute or solvent molecule. Ibig sabihin, kunwari, ethanol yung solvent mo. Tapos naglagay ka ng isang yung solute mo ay nagre-react pala sa ethanol. So magbabago yung yung peaks mo kasi habang nagpo-progress yung reaction, nag-iiba yung compound, yung product, nag-iiba yung species na andun sa solution. Ayun. So, next ay spectrophotometry. So, ito na yan. So, spectrophotometry is the measurement of light at selected wavelengths. The technique depends on the light-absorbing properties of the analyte or interest or a derivative of the analyte. Depende dun sa incident light natin kung anong gamit. Pwedeng UV, pwede sa visible region, or pwedeng both UVVs, or pwede ring IR region. Depende. The intensity of transmitted light passing through a solution that contains an absorbing substance or chromogen. Ang tawag natin sa isang absorbing substance ay chromogen, is decreased by the absorbed fraction. This fraction is detected. So, nade-detect, meron tayong detector sa dulo, measured and used to relate the light transmitted or absorbed to the concentration of the analyte of interest. So, ito yung isang block diagram ng isang typical spectrophotometer. First, we have the light source. The light source, the monochromator, the sample holder. Minsan may wavelength selector pa dito, pero dito sa block diagram na to ito ay isang photodetector, then readout. Or yung LED display, or ngayon hindi na LED display ang gamit, diretso na sa computer. So light source, base dapat sa naaralan natin sa analytical instrumentation na subject. Hindi ko alam kung anong subject yun sa inyo. Sa amin, meron kaming instrumentation na analytical chemistry. So light sources include incandescent lamps, hydrogen or deuterium lamps, and lasers. Incandescent lamps use a tungsten filament. Housed siya sa isang silica envelope na merong mababang pressure. Vapor lamp, or yung tinatawag natin na low iodine. Yun yung pagkakaalala ko, low pressure iodine or bromine vapor andun sa lamp. Bakit may ganon? Kasi ini-increase na yung lifetime ng filament pag meron tayong low pressure na iodine or bromine vapor dun sa lamp. So incandescent lamps na merong tungsten filament, isa siyang light source. So dahil yung tungsten lamp, hindi siya nagsusupply ng sufficient radiant energy below 320 or below 350 nanometers, ay hydrogen or deuterium lamps ay ginagamit for measurements sa UV region. So next ay after ng light source, meron tayong monochromator na tinatawag. A system which is a system for isolating the incident light for a desired wavelength na gusto natin. So, in-exclude natin yung mga yung ibang wavelength na ayaw natin. Kunwari, select natin, gusto natin 500 nanometers lang. Yun, pwede nating ma-select yun. So, ang ginagamit natin for spectral isolation usually includes filters. Filters. Usually, ito ay buong spectrophotometer itong nakalagay dito. Meron tayong light source, merong collimator, pang pang focus. Tapos sample holder, ito yung sample holder. Tapos yung filter wheels, yan yung filter. Or minsan, gumagamit din ng diffraction grating. Sa physics natin, di ba, pag nag-diffract yung light, meron siyang nagse-separate yung various wavelengths ng UV light. Yeah. So the simplest filters are thin layers, usually of colored glass. Ayun, the spectral purity of the filter or the monochromator is described in terms of its spectral bandwidth, which is described as the width in nanometers of the spectral transmittance curve at point equal to one half of the peak transmittance. Okay? Wait lang. Pen? Ganito yun. Kunwari, ganyan yung peak. Sorry. Ay, wait lang. Eraser. Eraser. Pen ulit. Ah, yan. Kunwari, ganyan yung peak. Yung ano, yung tinatawag natin na ito yung peak transmittance. Tapos ito yung half yun. Tapos merong ano dito, di ba may nanometers to. Nanometers. Ang hirap naman mag ano. Tapos ito yung one half. One half. Ayan. Yan yung one half. So ulitin natin. Okay, balik ako sa laser. Laser pointer. So, the spectral purity of a filter or other monochromator is described in terms of its spectral bandwidth, which is defined as the width in nanometers of the spectral transmittance curve. So, yan yun. At a point equal to one half of the peak transmittance. So, yan yun. Usually 50 nanometers yung bandwidth na yan. So, these wide bandpass filters are not used in most spectrophotometric applications. So minsan, bukod sa filters sa diffraction gratings, gumagamit din tayo ng prism. Kung nakita na kayo sa physics again, diba meron yung prism, yung triangle. Tapos nagse-separate din yung wavelengths ng light doon. So, next slide. So we have here a cuvette. Yung nasa taas, kinuha ko sa SCUG, yung SCUG na analytical chemistry. So a cuvette is a small vessel used to hold the liquid sample in the light path of the spectrophotometer for measurement. Usually, square or rectangular yung cuvettes kasi kung kunwari, round siya, pwede siyang kahit transparent siya, pwede pa rin siyang mag-reflect or mag-diffract ng light. So, ang ginagamit usually sa UV-vis spectrophotometry ay itong fused silica or quartz. Bakit? Kasi makikita natin siya na pasok siya sa UV-vis region. Sa IR, ang ginagamit usually itong KBR. Kung naka-experience na kayo ng IR, ang ginagamit dyan ay yung KBR na pellet. Pwede ring nodule mol, pero wala dito. Pwede ring nodule mol. Pero usually, ang ginagamit ay KBR pellets. Sa UV-vis, ang ginagamit natin at saka mostly in mga spectrophotometry applications, ang ginagamit natin ay yung fused silica or quartz. Ito, sample ng cuvettes na may iba't ibang shape. Meron, depende sa volume na kailangan nyo. Ito ata ay 3.5 ml. Ito ay 1 ml. Hindi, micro ml lang to, 0.1 ml. Diba? Sobrang liit. Ang galing. Ayan. So, second to the last part before the readout, we have the photodetector. There are two types, the photo multiplier tubes and the photo photodiode array. So, photodetector, that's striking it. So, di ba, merong light dito, nag-absorb na tong cuvette. May incident light, may monochromator, nag-select tayo ng wavelength. Meron tayong sample holder, andun yung sample. Nag-absorb na yung ano dyan, meron na tayong decrease intensity, tapos yung may iwan na yung reduced na intensity from the sample holder, madidetect nung photodetector. madedetect ng photodetector, tapos ita-translate niya ngayon yun into a signal to the readout. Ayan. Yung intensity, yung detector surface, yung intensity ng light ay depende kung ilang electrons yung ma-release dito, nakadepende sa intensity ng light na may iwan doon. So since ito yung incident light natin, itong incident light natin from the monochromator, nag-absorb na to, ang kailangan natin yung na-absorb. Ito yung yung light na passing through the sample. Yun yung i-detect ng detector. Isusubtract niya ngayon dun sa incident light para makuha natin yung absorbance ng sample. Di ba? Ayan. So, sabi ko nga kanina, the two main types of detectors are photodiodes and photomultiplier tubes. Photomultiplier tube is an electron tube that contains a cathode or a light-sensitive metal and a series of diodes. Sir, ano yung diodes? Ito, dynode siya. Ang ginagawa nun ay ine-enhance niya lang yung signal. Nakalagay siya sa isang glass enclosure. Tapos yung anode, siya yung nagko-collect ng ng photons, ng signal from the photomultiplier tube. Ayan. So when the photons strike the cathode, the emitted primary electrons are attracted to the first dynode, causing the emission of 3 to 6 secondary electrons. Siguro mag-chat ako sa inyo ng isang YouTube video. Ang ganda, merong magandang panoorin yung electrons niya. So, kunwari, may nag-strike na, okay, ulit tayo, pen. Ito kunwari, isang electron, isang dynode. Ito yan. Okay, pen. Circle to. Kunwari, may isang dynode. I-strike niya to. Yan yung first dynode. So, after nung first dynode, mag-emit to ng secondary electrons, 3 to 6. Pero yung intensity ng secondary electrons, relative pa rin dun sa incident na electrons. So, hanggang dumami, kasi madami yan, nakapalibot yan sa isang circle, paikot-ikot yan. Tapos, ang ginagawa niya lang, ayun nga, basically, ang key takeaway doon, ine-enhance niya yung signal. Ayan. Or ina-amplify niya yung signal. Usually, sobrang taas from the initial na electron na signal. So, next ay yung photodiodes or light sensing diodes. These are detectors which usually yan na yung ginagamit sa hospitals, yan na yung ginagamit. Pero sa laboratory, sa chemistry, photomultiplier tubes pa rin. Kasi sa hospitals, kaya gumagamit ng photodiode array. Ang difference nito kasi ng photomultiplier tube ay selected wavelengths lang yung maano natin. Ito, nasa-select niya na yung simultaneous na wavelength. So, sobrang bilis ng analysis. Kailangan sa hospital kasi minsan madaming backlogs, ganun. Meron na-select niya na yung various wavelengths. Compared dito, na selected wavelength lang. Kung ano lang yung sinelect mo, yun lang yung i-read niya. Ito, na-read niya na yung various wavelengths. Ayan. So, yun yung basically. So, ayun nga, photodiodes are popular detectors because they can measure light simultaneously at many wavelengths. So, at mabilis din kasi gumagamit siya ng array. So, they can be arranged in a linear array of hundred of diodes. Ayun. So, calibrated siya with response to a specific wavelength by its placement in the array. So, ito, specific yung wavelength. Yung red na wavelength, orange, ganyan. So, yan. Next ay reflectance photometer. So, These reflectance techniques are used in many point-of-care applications in analysis of macroscopic urine test strips. Uh, After siguro sa immunoassays, madi-discuss natin 'yan. They are also used in many of the measurements performed on the vitros or the orthoclinical diagnostics series of analyzers. So, ano ba yung reflection? So, reflection occurs when light is deflected by the surface of a substance. Similar yan sa isang mirror. Yan, reflection. The reflected light is in the same plane as the incident ray and is perpendicular to the reflecting plane. Uh, Ayun kasi, hindi lang naman mirror yung nagre-reflect. Lahat ng bagay technically ay kayang mag-reflect. Nagba-vary lang yung reflectance niya. Ayan. Specular reflectance occurs when light is reflected from a smooth or mirror-like surface. Ayun nga, sabi ko nga, madaming iba't ibang type ng reflectance. Dapat na-aral nyo na yun sa physics ninyo. Physics, yung unang calculus-based na physics. So, specular reflectance occurs when the light is reflected from the smooth or mirror-like surface. This is contrast with diffuse reflectance, which occurs when light is reflected from an irregular surface. So, specular reflectance is used usually as an analytical technique to measure sample concentrations in reflectometry instruments. A reflectometer measures the amount of light reflected by a colored reaction product on a reflective surface composed of a paper or plastic. The term reflectance density describes the amount of light absorbed by the colored reaction product on the surface, which is inversely proportional to the light intensity reflected by the sample. As the sample concentration increases, so habang in-increase natin yung sample concentration, nag-increase din yung kanyang intensity. So pag nag-increase na yung kanyang intensity, yung amount ng light na reflected kasi increase na yung intensity ng sample natin, nagde-decrease. The reflectance is therefore inversely proportional to the concentration of the analyte of interest and is nonlinear. So it requires a mathematical algorithm to linearize the data and determine the sample concentration. So ito, isang block diagram, okay, laser, pointer. Isang block diagram na isang reflectance photometer. Ito yung laser incident light natin, ito yung test strips. Kunwari, yan yung macroscopic na urine test strip. Tapos reflectance, since reflectant to, may reflecting light. Kinokollect siya ng isang collimating lens. Katulad kanina sa block diagram na isang spectrophotometer, merong filter. So, any filter, kung anong depende sa device, pwedeng katulad nga kanina, grating o prism or filter. At dito sa reflectance na block diagram na to, ang gamit ay filter. Tapos, after nun, kokollect natin yung light, filter, tapos ifo-focus natin ngayon gamit ng focusing lens to a photodiode. Yan na yung detector. Sa isang reflectance photometer, ang gamit na detector ay photodiode array. So, pre-amplifier, in-amplify niya lang yung data. Tapos, ito na yung computer system, yung detector o yung readout. Okay. So, next ay didiscuss naman natin ay fluorescence or fluorometry. So, fluorescence occurs when a molecule absorbs at one wavelength and emits light at a lower wavelength. Importante yun. Fluorescence occurs when a molecule absorbs light at one wavelength and emits light at a longer wavelength. An atom or molecule that fluoresces is called a fluorophore. So, isang atom or molecule na nag-fluoresce ay isang fluorophore. Fluorophores are frequently used as labels in immunoassays and flow cytometry. Ayan. So, fluorometry is the measurement of the emitted fluorescence. Fluorometric analysis is a widely used technique that is quite more sensitive. Mas sensitive siya than absorption spectrophometry. And the increased sensitivity results from the fact that the emitted fluorescent signal comes directly from the sample. So, direct siya mismo dun sa sample. ito ay isang block diagram kinuha ko sa Skoog from a fluorometer. Ah, so, ayun nga, fluorescence intensity is measured with the use of a fluorometer or a spectrofluorometer. The instrument contains the same component found in a absorbance photometer. Pero ang difference, mamaya explain natin. But there are some important difference nga. Yung isa dyan ay ang fluorometer ay uses filter monochromators to isolate. So filter monochromators yung gamit to isolate emission wavelength, whereas a spectrofluorometer uses a diffraction grating. Oh, baka lumabas din dati sa word exam namin. Ala ninyo. A fluorometer uses filter monochromators to isolate excitation and emission light, whereas a spectrophotometer uses a diffraction grating, similar to a typical spectrophotometer. Okay, fluorometer, filter, spectrophotometer, diffraction grating. So, mercury arc lamps, xenon arc lamps, or xenon mercury arc lamps and lasers are typical fluorescence sensors. So ito mercury arc lamp, ito yung exciting beam. Ito katulad nung similar kanina, nagko-collect lang to ng light. Para siyang collimating lens, glass lens, collimating lens to. Tapos may apertures din. Define niya yung ano yung intensity ng light beam na ano natin, na mako-collect natin. Tapos meron tayong excitation filter. Siya yung nagfa-filter ng kung anong wavelength ang isi-select natin. Tapos meron tayong sample cell. Sample cell, tapos dito may filter ulit, emission filter. Sir, bakit may dalawang filter? May excitation filter, may emission filter. Kasi yung excitation filter, iba yung wavelength na ginagamit. Okay, laser na lang. I-excite muna natin yung sample. Excite muna. Kunwari, ano bang pyridine, ganyan. Hindi. Rhodamine 6G, kunwari. Excite natin yung sample doon sa isang cell. So, meron tayong excitation wavelength. Dapat iba yung excitation wavelength doon sa emission wavelength niya. So, meron tayong emission filter. Diba, mag-fluoresce siya. So, iba yung wavelength niya pag nag-emit niya siya ng light. Ayun. Kasi, diba, may light, papasok doon, mag-fluoresce siya. Tapos, bababa yung wavelength from the intensity light. Tapos, dapat naka 90 degrees siya. Kasi, pag naka-straight siya na ganun, straight siyang ganun, edi mariread din ng detector yung incident light natin. So, ayun. So, kaya merong light absorbing surface din dito para hindi magkaroon ng stray light dito from the mercury arc lamp. Dapat ang minimeasure na lang dito ay yung emission ng fluorescence na sample. Tapos, pag after nun, meron tayong detector. So, detector, tapos readout. Usually, ang ginagamit sa fluorometry ay photomultipliers sa mga spectrofluorometers. Pero minsan meron ding photodiode arrays. So, an application of fluorometry is the FPIA or the fluorescence polarization immunoassay. Matutunan natin yan sa immunoassays. Wherein, for example, the presence of an unknown quantity of a therapeutic drug. Kunwari, nagtetest tayo ng isang drug, mag-compute siya sa fluorescent labeled analyte, magbabind siya dun sa antibody, tapos mag-fluoresce siya. So, magiging fluorescent siya. So, ma-discuss natin yan pag sa immunoassay na. So, since fluorescent na siya, ma-read na natin siya sa fluorescence. Ayun, usually ang ginagamit ay ito, ang conjugate, tapos antigen. Meron tayong high polarization tsaka low polarization na incident light. Depende sa gagamitin mong pang fluoresce. Okay? Tapos yung agent, i-discuss na lang natin yung ginagamit na fluorescence agent. sa immunoassay. So other than that, there are many luminescent techniques. So ito, FYI na lang, chemiluminescence is a reaction that produces light without producing heat. So in chemiluminescence, the excitation process is caused by an oxidant such as hydrogen peroxide, that magkadikit yan, sorry, hypochlorite or oxygen, and involves the oxidation of an organic compound such as luminal, luciferin, or an acridinium ester. So the reaction occurs in the presence of a catalyst. Meron tayong catalyst na ginagamit. Usually alkaline phosphatase, peroxidase, or Swadis peroxidase, microperoxidase, or other metal ions or metal complexes. So next ay bioluminescence. It's a special form of chemiluminescence na magkadikit found in biological systems. In bioluminescence, an enzyme or photoprotein increases the efficiency of the reaction. So meron siyang attomole or zeptomole na detection limits. Sir, ano yung detection limits? Ayun, detection limits yung LOD, limit of detection natin. Luciferase and aquarin are two examples of biological catalysts. So ginagamit siya sa immunoassay na tsaka probe assays ng DNA. So lastly ay electrochemiluminescence. So it differs from chemiluminescence in that the oxidative species is then generated from a stable precursor at the surface of an electrode. So usually ang ginagamit ay ruthenium chelate. So ano yung advantage? Ayun, hindi naman lumalabas sa board exam. The advantage of this process is improved reagent stability. Ayun, reagent stability lang. Kasi complex to na inorganic complex. Ruthenium chelate ang gamit. Okay. Ito ay last na ng spectroanalysis natin. Next time ay mag-deal naman tayo sa next week. Chromatography, electroanalysis, mga cyclic voltam, ganyan. Lastly ay nephelometry and turbidimetry. Turbidimetry and nephelometry are analytical methods to measure light scattered by particles in solution. Turbidimetry measures the reduction of light transmitted to a colloidal solution. The reduction in source light results from light scattering, reflectance, and absorption. So it is used to assay smaller particles at higher concentrations. Nephelometry is based on detection of the portion of light scattered or reflected by the particles in the solution toward a detector, not in direct path of the transmitted light. So it is the method of choice for assaying larger particles at lower concentrations. So madidiscuss ulit natin to sa immunoassay, yung specific application niya sa medical field. Ayan. So, pero important to take note, anong difference ng turbidimetry at nephelometry? Yung turbidimetry ay used to assay smaller particles at higher concentrations. Yung nephelometry ay used to assay larger particles at lower concentrations. Yan. Important yan. Okay. Stop sharing na muna ako. Inom lang ang tubig. Okay lang, inom lang ang tubig. Class, pero magtatanong lang ako sa inyo, may nagets nyo ba yung discussion? May hindi ba kayo nagets? Since sync class, unlike an asynchronous class, I like to ask questions if nagets ninyo. Gets ba? Chat, reply or unmute kung may magsasalita.
Papa po. Medyo limot na po. Anakim eh.
Anakim. Oo, Anakim. Although, lang naman to, review. Di ba? Dapat review.
Opo.
Ayun. Itong part na to, hindi pa tapos. Meron pa siyang latter half. Didiscuss natin next week. Pinilit kong hanggang next week kasi pag sinagat ko ngayon, next week mag-exam na tayo. Kaya hinati ko na lang to. Yung analytical chem na part, hindi ko naman... I see. So, gets naman. Madami lang po and mabilis yung mga information. Kaya hindi may digest lahat all at once. Okay. Dapat pala re-record ko to, no? Hindi ko ni-record eh.
May nag-record naman po ata sa amin.
Ay, may nag-record sa inyo? That's good. Okay. Ah, okay.